We'll talk about semantics in data architecture, which is, of course, now a very hot topic. And let me just start by introducing myself a little bit. Based in Helsinki, Finland, sitting now here in my home office in Helsinki. Been doing this now for 15, 16 years, I think, and mainly in the last decade or so, I've been working with data modeling and data modeling related topics, which has recently included a lot of work in data governance and data products, especially kind of data mesh related thinking and metadata management overall. But increasingly now with the kind of coming of age of AI solutions and their need for context, this data modeling topic has been kind of coming to forefront in that angle, and we'll go into that detail in a moment. But I have my own little one-man consulting company called Data Core Consulting. I do all sorts of work in these areas with mainly sort of larger enterprises here in the Nordics, and the occasional speaking gig and trainings and whatnot also abroad. That's my kind of day job. I have a little side project. I don't know if you have heard of Helsinki Data Week, but I'm one of the founders of that. Another great conference actually this year in last week of October in Helsinki. You should all be there. It's going to be amazing. So check out helsinkidataweek.com. We also have a little podcast relating to that called Helsinki Data Mafia. There's actually a new episode coming out tomorrow, I think. And yeah, bunch of things where I've been speaking at. Used to work at Elli Technologies, a data modeling startup, led data platform development at a sort of large Finnish forestry enterprise, and so on and so forth. So those sorts of things. And as I said, recently, this background has kind of led me to the topic of semantics. And obviously, I've been talking about semantics and working on semantics for a long time. And this has mainly been in the context of kind of overall metadata management and data modeling for humans. But the big question, basically, which is sort of ironic, is that we don't necessarily agree on what semantics means. But I'm trying to be kind of very sort of pragmatic about this. And I consider semantics to be something that we kind of needed always. Humans need semantics around their data because they need to know what these things are that we have data about so that we can connect our data into actual business and the terminology that the business uses. We need to be able to classify and categorize the data that we have, that we know that, okay, you know, this is type of customer and we have other types of customer and they behave differently and so on. And we need to understand something about how these different things are connected in real life so that we understand the connections between the data objects that we have at hand. And these questions are something that we always needed. We, you know, if you have ever done anything relating to conceptual data modeling or glossary work or anything, you've always been dealing with these questions. But now with AI, we can no longer trust the human to, you know, find Pete from accounting and go ask them what this data actually means. We need to be able to tell the AI, the agent, whatever, you know, solution it is, that this data actually is about that thing. And this thing also features in that other data set. And it's no longer just for human users. I do find it amusing that now that the user of this semantical information is a machine, it is suddenly way more interesting to many engineering leaders. But it's still nevertheless a super important thing. And if we go into what semantics kind of means and what do we have to manage when we want to manage this layer of metadata, of understanding around our data, we basically have three kinds of areas we have to deal with. So my approach is very sort of practical and not very academical, but I do want to use some academical words because these are very good words. Regarding the things that we have data about, this is mainly a question of glossaries or vocabularies, if you want to use that term. So it's a question of what does customer mean? How, you know, how does the customer differ from the client term? Are they the same term perhaps, or is there some sort of difference? And you know, do we have synonyms and so on and so forth? This is glossary work that we need to do to understand what the data is actually about. Likewise, when we deal with classification, categorization, and hierarchical data, we have to understand taxonomies. And taxonomy is sort of academical sounding word that we had to kind of avoid in the earlier days, but now it's on the forefront of these semantical metadata questions. a taxonomy in its very simplest form is, think about animals. So you have a mammals and you have a cat, and cat is a mammal, and mammals are all animals, and so on and so forth. You have this tree of classification. So that's a taxonomy. And ontology then is the big word now, the word of the year, I suppose, in this business. Ontology has a very specific meaning. I'm not going to go deeply into it right now, but an ontology basically is a formalization of the understanding how things connect to each other. So it's not just the words themselves, these are part of the ontology, of course, but it's also the connections between those words. So how does a customer relate to a delivery, for example? And what do we know about deliveries? How are the deliveries connected to the routes that are being taken during those deliveries, and so on and so forth? And this ontology explains how these concepts link to each other. So all of these taken together, glossaries, taxonomies, ontologies, or vocabularies, taxonomies, ontologies, if you want to use kind of more knowledge management terminology, it is about understanding what our data means and how it connects to actual business. So this is the semantical information, the metadata that we need to give the AI agents that we have. And this is my very simple kind of view on what do we actually mean by semantics. It's basically terms, definitions of terms, and then relationships between different terms, either taxonomically or kind of ontologically in terms of how they are associated. Now then, semantics is something that we had been talking about. I mean, I've been in this business for 15, 16 years, and already when I started, we had semantic layers. We had BI semantic layers. We didn't call them necessarily BI semantic layer, but we did talk about semantic layer, and we did talk about semantic models and whatnot. And I still see this kind of traditional BI focused talk of semantic layers kind of mixing into this discussion of semantics. And one of the goals that I want to achieve here today is to perhaps clarify these distinctions a little bit. So when I talk about specifically BI semantic layers, it is this kind of older concept that we used to have for a long time, which is sort of a step in the right direction. So you have some sort of a data platform. Let's see if I can get the pointer up. There we go. You have some sort of system somewhere, and you have a data platform, perhaps a data warehouse, whatever that might be, from which you then grab data into what you call a semantic layer, and you create your little data sets which have definitions around them. So you have a table in the semantic layer there, some sort of an object, and you have attributes in it or properties, and you have some definitions that, this is customer lifetime value, and this is how we define it here. This is part of this semantic object, this semantic model that lives in your sort of semantic layer. But the problem with this is that even though it's fun to have kind of a semantic layer in which these terms have been connected to the data objects, this is not the reality of the whole organization. You'll have a whole bunch of other data solutions utilizing data from perhaps completely different data sources, or even utilizing the data from the exact same data platforms that are not necessarily part of your so-called semantic layer. This might be in, I don't know, Looker or Power BI or something, but these are the data sets that exist in some other format. And the problem here is that we've created, with this sort of BI-focused semantic layer thinking, we create isolated silos of semantics at solution level. The individual solution here, it used to be a cube. Nowadays, it's maybe something else. The individual solution here has some semantics kind of inserted into it. But the information that you have here about customer lifetime value, what does that mean? Has nothing to do with the customer lifetime value that is also calculated here because some other team has created this solution. The definitions, the semantics between these two solutions are not connected, and we have a whole bunch of solutions that do not have semantic information appended to them or added into them at all. So we have basically a subset of data that has limited amounts of siloed, isolated semantics in it, and then the whole other picture is basically unknown from a semantical perspective. So this cannot be the end goal here. So let's keep that in mind now, kind of at the back of our heads, and let's move towards solutions, at least possible solutions. So how do we capture semantics in the first place? Now, I come from, as I mentioned, from sort of data modeling background. And the way I see this is that you don't necessarily need to be knowledge management expert and expert in ontologies and everything to be able to start this work on figuring semantics out. Data modeling is a way to figure out semantics. It's just that we have focused so much on the individual solutions, technical models, that we have perhaps forgotten something about what data modeling can do from a semantic perspective. To explain that, I want to go through kind of 3 levels of data modeling, because I will be referring to these 3 levels as we go forward here today, and I want to make sure that we're all on the same level. I see data modeling as a kind of continuum between purely business-focused thinking on the other hand, and purely sort of IT and technology-focused thinking on the other hand. And conceptual modeling is where we are at the business end of things. We're figuring out what the business looks like in data terms. What are the things of interest in the business? i.e., we're modeling the business. We're not modeling a database. We're not modeling a solution. We're not modeling a system. We're modeling the business in terms of data. When we start figuring out then how we should best organize that data for a particular use case, that's when we come to logical modeling. And logical modeling is already us not necessarily looking directly at the business anymore, but we are kind of focusing now at an individual solution and figuring out, do we want to do this? Is it going to be dimensional modeling? Is it going to be data vault perhaps, or something like that? This is a question of logical model. The business model at the conceptual level has nothing to do with dimensional or data vault or normalization or anything. This is just an understanding, and you'll see soon what I mean by this, an understanding of what things exist in the business and how they are related to each other. The logical model is where we figure out, oh, we want to do this shape or this structure of model for a particular use case. And then we move to the IT end of things, where we start figuring the physical data model out, meaning that we have a desired structure for the information that we get from business, and we want to implement that in a particular technology. So we might then deal with constraints and indexes and so on and so forth, which has nothing to do with the actual business. It's just optimization of a specific storage solution. So I use these 3 levels. I've been using this for many, many years, and I think it sort of makes sense from an intuitive perspective. I know that some people prefer to divide this continuum into 2 parts, so they all only talk about logical and physical modeling perhaps, or maybe you have 4 parts here: contextual, conceptual, logical, and physical, or something like that. I just think this is intuitively a good way to kind of comprehend different levels of abstraction in data modeling when it comes to the kind of business IT divide here. So why this is important is because we want to capture that semantical information and maintain that. And semantical information basically exists here in the conceptual model. This is a very sort of straightforward conceptual model of bank and accounts in a bank. So what we have here is, again, it is not a diagram of a system or a database. Nowhere in here does it claim that any of these boxes represents a table or file or anything. We're just simply saying that a thing called customer exists. The thing called customer has credit cards. This is one-to-many relationship, so they can have multiple credit cards, and they own 1 or more accounts. There are 3 kinds of accounts. This is, I think, the Barker notation for subtypes. So you can see there are 3 types of accounts. There's 2 types of counterparties. Persons and organizations. Both of them can be customers. Only persons, only people have access to accounts. And then we can see that, okay, the customer owns the account, but then a different person might have access to that account. Maybe that's, family account or something like that. And that different kinds of accounts, and credit accounts are connected to credit cards because the credit account, the credit card uses the credit account, and so on and so forth. You have the banking transactions and account statuses, and they're managed by branches which are part of business units. This is merely a description of what exists in the business. This is the conceptual model, and this is what we need to figure out semantics of this organization. What is missing from here is sort of the glossary angle. So when I work with conceptual models, I always add definitions. So you could, I don't know, double click on that business unit, or maybe you have a separate document somewhere which says by business unit, we mean this. It's a division of the bank. By branch, we mean local office or something like that, which could be, independent enough to kind of manage accounts separately. Whatever that might be, we define what a customer is. We define what a credit account is. We define what a mortgage account is. We attach definitions, the glossary, into the things that the conceptual model defines. Now, if you have done data modeling, if you have at least, basic understanding that, okay, you can start from the conceptual model and then you create a logical model and you move towards physical model, you would probably consider that this is something that we do when we start designing new data solutions, or actually any solutions. It might be an operational application or whatever, but this is kind of a design artifact perhaps. And that is true, but I think there's something that we kind of need to change now in the way that we utilize data modeling. And I think the change is because we need that semantical information that we capture here. We understand the business in some way, and we capture that understanding by creating conceptual models. But the design pipeline, as it were, from this towards logical models, towards physical models, and eventually then the data product, this we understand relatively well. This is sort of basic thing. This has existed as sort of practice for, I don't know, since 1970s or something like that. But this means often that we only utilize the conceptual model and the semantics that we've captured in it during this design process. And once the data product is ready, then these design artifacts, these model diagrams, these are forgotten, and maybe they exist somewhere in a Confluence page somewhere or something, but they are never updated anymore, and no one is aware that this model has been created and this understanding has been captured. What I think we need to do is to recognize that we can use this exact same method at the same time as we are doing the design for a solution. We may use this conceptual model to actually kind of as a discovery tool for enterprise semantics, meaning a sort of permanent repository of meaning in the organization that explains what the customer is, what a mortgage account is. So there's kind of this one-off usage of conceptual models as part of the design pipeline, of the design process. But then we have this usage of conceptual models that I am now advocating in many places and seeing good results out of it. And we'll get back to that in a moment. That we use it to capture enterprise semantics, which also then allows us, because the same model is being used as the basis of the design of the solution, it is being used to create information into enterprise semantics, which might be a knowledge graph or something. We're not going into that right now. This allows us to then understand that, all right, in my data product, I have, or it doesn't have to be a data product, any kind of data solution. I have a table or whatever technical object here, which is about this concept, which allows us to map that data, the data object, to the meaning, the semantical object, the term, business term, in our kind of semantic layer here, the true semantic layer. And this should work across all kind of data products. We create all sorts of data products from all sorts of conceptual models, but we're constantly feeding that information that we discover into our enterprise semantics. What we should be aiming at is a system that looks something like this. We have the sort of data plane, as it were. We have our source systems, the operational data. We all know that the engineering work is to map basically all these source data objects into some sort of data products or whatever data solutions. If you don't like the term data product, that's fine. Where this data is intended to be shared and reused by all sorts of AI solutions and applications and humans via visualizations or whatever. So we all kind of, as data people, we understand this sort of intuitively. But what I am saying is that to make this data utilization context aware, i.e. by adding semantics around the data so that especially AI can understand that, we need another layer entirely which contains the business context. And this, I'm using the terms knowledge plane and data plane. These are I've stolen these terms from Andrea Choya's writings, which I really recommend. He's writing excellent stuff about data products and semantics and everything. That we have this actual physical data on our data plane, but then we need to have separately a layer in which we manage just the semantics, because we need to have a data to meaning mapping. This is a sort of physical from to mapping here, from this source system to this data product. Data flows here. This is just a semantical mapping, a semantical link between the thing, customer, and the object in which we store data about that thing. And this has to be a many-to-many mapping. This cannot be just that, we define customer 7 times because we have 7 data products relating to customer. No, we manage this as a separate layer. And what data modeling does here then is that the design process feeds into this work that we do creating these data solutions. And the discovery process feeds into this knowledge plane with all the semantics that we've discovered. So what that looks kind of as you scale this up, and this is work that I have been doing recently with a bunch of organizations, is that now this is perhaps related to data mesh type of a work, but it doesn't necessarily need to be a mesh. It's just that you have some kind of domains in your business. You have finance data, you have R&D data, you have operations data, whatever that might be, in which usually you have different sorts of data solutions that are created to serve that data to others. It might be a sort of formalized and federated data mesh model. It might be just the way the things are. But what we usually want to have is an understanding of what these different domains contain. So a conceptual data model that explains that finance looks like this. Finance has information about, I don't know, accounts and transactions and payments. The domain level conceptual model explains that this is what we have about this domain. Then we have data models that explain individual solutions, individual data products. Those might be conceptual models if the domain model is super big and you are only having some small part of that in the data product. Perhaps you want to have a separate conceptual model describing that. But then you have those logical data models describing what the structure of data within that specific product is. And these are, of course, connected, or they should be, that you can tell everyone who's looking at this from outside that here's my logical data model explaining how this data product is built, and it is about these sorts of concepts which connect to the rest of the domain model in this and that way. And when we have these same models then from all domains and all data products, we're able to connect them via these business glossaries, taxonomies, ontologies, which are kind of independent from the actual solutions here. They can be domain specific still. You can have, finance glossary and you can have R&D glossary, but they have to be interconnected so that you're able to say that the data that we have here in this particular solution is actually, because it is about a thing that connects to another thing here, it is actually also semantically related to this data product. So this is what I mean by enterprise semantics, that we are able to gather information from all these domains, from all these data solutions that we create into some sort of a coherent, separately managed repository of understanding. What that looks like in practice, this is a diagram that is based on Juan Sequeira's presentation. I really liked this, so I tried to reproduce it. What Juan is saying about semantics is that semantics is basically governed metadata. And to make this whole thing work, you need to govern 3 kinds of metadata. You have what Juan calls business metadata, that is the glossaries, the taxonomies, the ontologies, where you just simply manage the information about what a customer is and what types of customers do we have and how the customer connects to a delivery, for example. You also need to have that mapping. So you have the technical metadata of the data plane there. You need to have information about, your schemas and tables and columns as metadata somewhere so that you can map them. Your tables are mapped to concepts, your columns are mapped to properties of those concepts. And this is all metadata that needs to be governed in the organization. Now, many people think that this means immediately that, okay, I need to use, I don't know, OWL ontologies or start building RDF compliant knowledge graphs or something. It doesn't necessarily mean that. All this is saying is that there needs to be governed metadata about these things, which information can then be deployed via different sorts of metadata interfaces. So perhaps you have an enterprise knowledge graph. That's perfectly possible. I mean, it's really a sensible thing to have in the end, because you want to be able to manage that metadata in sort of interconnected way. You might be able to deploy some of that metadata into that BI semantic layer so that you have the definitions of things directly connected to the technical objects in your semantic layer for BI. You might have applications that it's in itself need that information. You might have data products that need metadata, that this data product is about customers and prospects, and that data product is about leads. So you want to have that understanding of those terms exposed also via your data solutions. But this is just a way, there are different ways of deploying that metadata into different interfaces, which are then used by your AI and absence humans. So I think there's a problem in this industry that we tend to confuse the means of sharing and storing information with the information itself. And I think especially with semantics, it's very important for us to understand that semantics is information, and knowledge graphs and semantic layers and whatnot are where we might deploy that into, but we have to figure out how to manage it before we can deploy it. No, practical use case. So I've been working, well, for a long time already with one of my clients, and we do something like this. So we have basically a bunch of conceptual models that have been created over time of different domains and whatnot, where we define business entities, we define what the customer is, what types of customers there are. These are usually done on a use case scope. So there might be a new project coming up, and you want to figure out what information do we need in this project. So you create a conceptual model to figure out the scope and the objects there. But then these are often kind of raised to the domain level, that these 3 projects here are all about finance data. Now we can create, basically combining all of that information, we can create the finance domain model. But what we have started to do there now, and this is also something that I'm seeing in other organizations as well, is that we're now starting to formalize that information that we capture in conceptual models into kind of glossaries or vocabularies, where we have definitions in place, we have synonyms, we have acronyms, we have mappings between the finance glossary and the R&D glossary, or finance and logistics glossary, so that we know that when finance says customer, logistics says client, they are actually the same thing. Or are they? Maybe there's some specific difference. So all of that information goes into the glossary. And then when we find from that glossary that there are also sort of hierarchical terms, and there are terms that have classifications, we are capturing those classifications as taxonomies, so subtypes, classifications, customer types, B2B customer, B2C customer. Maybe there's subtypes of, I don't know, B2B customer, or even status codes or something like that. These are all taxonomies that usually have hierarchies. Your cost centers are hierarchies, and these classifications we have to also capture, because we are then able to build the ontologies, so that we take all of this information. We have the words, we have the meaning, we have the information, the conceptual models, how the words relate to each other, the associations, the relationships. We have the taxonomies explaining what the subtypes are. We can formalize that into ontologies, into a machine-readable syntax. This doesn't necessarily have to be, again, specific RDF thing, OWL thing, but I mean, it makes a lot of sense to use a syntax that already exists, and there's a lot of libraries and everything that does that. So why wouldn't you do that? I don't know. But once we are able to do this, we're able to take this information that we've captured and put that all into an ontology, and at an enterprise level, we can then deploy that ontology into a knowledge graph. So here's another kind of aspect that seems to cause a lot of confusion, that people confuse the ontology and the graph. Now, the graph is just an implementation or deployment of the ontology. For example, in my particular use case at my client, the ontology lives in turtle file, so it's a .ttl text file in which the ontology exists. That's, well, I mean, it could be queried with some means, but I mean, it's not very sort of easy to query and easy to use. So we just deploy the TTL files and the contents of those files into a knowledge graph. And then the graph, graph database itself then has interfaces which humans and agents can use. But you can't kind of start from here. What we are doing there, and what I think needs to be done, you have to start from the beginning. And I happen to think that the conceptual model is a super good way to get started, because it is a visual way to figure these things out. It allows you to identify the glossary, the terms at least that you need in the glossary. You get some general idea of some taxonomies. You figure out that, okay, there's actually 2 types of customers, there's 3 types of accounts. So those are beginnings of taxonomies. And you start to get elements that eventually go into the ontology as both kind of classes, the terms, the entities that you have in the model, but also as the relationships between those terms. And all of this can be formalized into RDF compliant ontology or something else maybe, but again, why not use something that some people have already defined? So this is kind of a process, and this is something that Jessica Talisman has been writing about a lot. So if you haven't read Jessica's writings yet, you really should. Jessica writes about ontology pipeline. She has coined this term and probably I think or even trademarked it, but this pipeline, meaning that you start from the beginning with the terms that you use, and then you start building structure around those terms. Eventually, you formalize that, and then you deploy it into a knowledge graph. And that is kind of an ontology pipeline. This is just a simplification of what Jessica is writing about, and I'm adding kind of my argument here that conceptual modeling is an excellent starting point for this pipeline. Now then, what's the kind of end result where we are aiming at from architectural perspective? I'm going to show you a sort of very busy diagram, but I'll explain the basics, so don't worry about it. This is something that I wrote a blog post on. I have a blog called Common Sense Data on Substack. You might want to check that out as well. But I didn't know what to call this kind of architectural thing that I created, so I called it semantic architecture. That's probably a bad idea because now it's part of the same buzzword bingo. But in any case, here it is. And let me walk you through what I mean by this whole thing. So the idea here is that we have the data plane here on yellow. So you have all your operational systems, your interfaces into them, your data platforms, data sets, your BI semantic models, dashboards, even, whatever, the actual physical data, your files, tables, columns, endpoints, whatever that might be. That lives on its own plane. But we need to have separately from that the knowledge plane in which semantic lives. And it's not that here in the BI, in Power BI or Looker or something that we would write into this semantic model that customer lifetime value is calculated as whatever. We don't want to do that here. We want to do that here. We want to have a term that says customer lifetime value, and then there's definition how we've calculated it, and then that is linked to all the different places in which customer lifetime value appears as physical data. And I think this is now missing from a lot of these sort of so-called semantic layer implementations and technologies. They do not separate the knowledge plane and the data plane from each other. They are mushed together, which means that all of your semantics is siloed inside a single solution here, which has nothing to do with another solution's semantics here. Now, we need to have that as a separate plane because it needs to be utilized by your Gen AI solutions, by your applications, by your kind of data cataloging efforts. If you want to figure out, what data do we have about logistics? That's a question that you pose at the knowledge plane. And you can then figure out that, we have, what terms do we have about logistics? We have routes and trucks and ships and whatnot. Those are terms that are defined in the knowledge plane and then connected to all the different places from which you can find the actual data. And then we build that knowledge plane via kind of all different sorts of semantic discovery. One of these being sort of conceptual modeling, that we have humans helped by AI, but mainly humans talking to other humans, creating these models. Often I see that the important thing is that the core of this knowledge plane is very strictly modeled by humans mainly. You can't afford to go wrong with the very core entities of your business. So those are often something that are built via sort of straightforward conceptual modeling practices. But then we might have knowledge bases elsewhere, documentation, Confluence pages, all sorts of guides or whatever. And we can use AI, and we should use AI, to identify from those knowledge bases terms and definitions that could be appended to the core knowledge that we have in the knowledge plane. And there are industry standards, all sorts of foundational high-level ontologies that explain very basic terms or industry-specific terms. Those are also very good. We can add them into the knowledge plane. We can connect terms. We can say that, in the industry standard, the term counterpart is the same as our term client, or whatever that might be. And if we deal with this knowledge plane in a sensible way, we are able to deal with all those kind of ambiguities and synonyms and differences here, and then just connect them to the right places on the data plane. But this is the crucial thing, that these are different planes and we have connected them via semantic linking. It's not that we have the definition here, it's that we should have some sort of, I don't know, URL maybe even, that links it to the actual term. And I've been building this now with some clients and discussing with many other people who are building similar things. The truth is that the technology for this is not very mature yet. So you can't buy this sort of a thing off the shelf. There are different ways to kind of work around this, and data catalogs can do some part of it and some part of it not very well. The problem with data catalogs usually is that they are focused on technical metadata from the data plane, and they are very, very limited in their capabilities of dealing with the knowledge plane of these terms and definitions. But that might also, in some tools, it's going slightly better than in others, and I'm seeing a lot of activity in developing these capabilities nowadays. But for some of my clients, for example, we've been just building this ourselves. So there's some sort of a knowledge graph somewhere, and we're setting URLs into definition fields of some semantic model and so on and so forth, pointing in the knowledge plane. But it's an evolving field. I think the key to this whole thing is that we built in feedback loops into the whole operating model of how this is done. So we can't just decide that, okay, we'll start a project now to build the knowledge plane for the whole organization. That's not how it works. We have to be able to utilize the work that we do at the product or solution level to kind of identify from the conceptual modeling work that we do, any work that we do, to identify new and updated patterns and templates. So if we identify that, there's a term that we have now defined that didn't exist before, we have to have an operating model where we are able to identify it from this kind of project or product level workflow and promote it to the enterprise or domain level, where it lives then on the knowledge plane. And then we have to have the feedback loop back, that when a new product is being developed or new project starts, that they are using and benefiting from the enterprise level semantics that we have documented at the higher level. And I see that the most problems that organizations have with these things, I mean, technology is not mature yet, but you can always work around that with that, somehow. But the problem is that if you create this, but you don't create an operating model around it, which loops this around, between these products and projects and the enterprise level, if you don't have these feedback loops, then it never survives long. So the survival of that whole architecture, of that whole kind of true semantic layer, depends on these feedback loops from product level workflows to the enterprise level and back. So that's kind of the sort of work that I'm doing. I'm doing a lot of work with these operating models and roles and responsibilities as well, because those also need to be figured out. It's, of course, often very dependent on the organizational culture and so far. It seems to me that sort of federated models seem to be working the best, that you have some people who deal with, the basic setup and everything, but then you have kind of domain teams or something like that that are able to then identify these reusable semantic components, as it were, and promote them for others to use as well. But that's perhaps a topic for another time. If you're interested in more of this kind of stuff, as I mentioned, I'm writing my own little Substack called Common Sense Data. And together with my mate Shane Gibson, we are writing a book called Modeling Business Concepts, which focuses on how this is done. So that book is being kind of openly developed at that. That's also a Substack. So there, and I'm hoping that Shane and I will get a very nice practical how-to guide out of that process. But yeah, that's my few words on data architecture and semantics. Do we have questions that we could answer at this stage?
Thank you very much. A really interesting session. So there was a question, what is your definition of semantics?
Yeah, I think I tried to answer it in the very beginning that, we have the understanding of what the words are that we use, like the glossary. We have the understanding of the structures of those sort of classifications. We have the taxonomy. And then we have all of this put together, plus the relationships, the associations between things. and that's sort of ontology part. So in very, very simple terms, I think semantics is words, definitions of words, and connections between words. And that's all there is to semantics, in my opinion.
I think, as you said, it's ironic, right? We all have slightly different definitions of it, but it probably can be debated for a while, but we should all try and agree on at least something.
Yep.
But how is your enterprise semantics different from a business glossary?
Well, I think a business glossary is a part of the enterprise semantics sort of layer. Business glossaries do not usually contain all the information that an ontology, for example, contains. Business glossaries are kind of vocabularies, the list of words and definitions of words. But to make that properly work, we need also the associations between terms. We need to know that, a cat is a pet for a human being, sort of information that is not part of just the term and the definition. So as I said, so terms, definitions, and associations between terms. So that association, those relationships, those are usually missing from a pure business glossary.
Yeah. Okay. And there was a separate question, but I feel slightly adjacent, which was, see if I can. What would you say the main difference between a conceptual model and an ontology is in this case?
Yeah, this is good. I've had long discussions with Jessica Talisman about this, and we wrote kind of articles. I wrote an article, Modern Data 101, saying that said basically that when you do conceptual modeling, you're creating an ontology, and then Jessica wrote another article saying, well, it's not technically an ontology. She's right. An ontology is very strictly formalized, machine readable description of all those semantical things. The conceptual model is usually not strictly defined, machine readable, and sort of formalized. It can be just, a few bullet points and post-it notes on a whiteboard somewhere. I try to add as much detail and form into my conceptual models as possible. So I try to name my relationships. I try to add all the definitions of the terms that I use, but it is not formalized in the same way that an ontology is. The information from a conceptual model can be formalized into an ontology. That's how I would perhaps explain the difference.
Okay. Would you almost say it's sort of like an ontology would be like a codified concept model with like more depth to it?
In a way, yes. Yeah.
I'm probably very much oversimplifying, but yeah, just my
no. But I
okay.
mean, I think that's. I mean, Jessica would probably disagree, but the ontology standards, the RDF standards, and so on, they have a lot more metadata than you usually get in a conceptual model diagram. So it's much more rich in terms of its informational content, but it's also way more complicated to work with. So that's why kind of conceptual modeling is a good way to get started and talk with people.
Yeah, I've dealt with OWL2, for example, and it's quite verbose. Yeah,
it's verbose. It's very heavy. It's a steep learning curve. But I mean, in the end, it's totally worth it.
Yeah, exactly. You get a lot out of it, but it takes a while to build up for sure. Okay. One question: do we have a template to use to manage business glossary and technical definitions?
In general, I think templates have been invented. I'm not sure if there's like a standard thing that everyone should be using. I, for example, have just created templates as I go for different clients. They want to document slightly different things and so on and so forth. But in general, I have noticed that it is good to have from very early stage a very sort of, at least within that company, that within that organization, very standardized way to gather information about both the terms and definitions and also the taxonomies, so that this is a subtype of that, and this is how we define it. So you kind of need to have a standardized way, but I don't think there's a global standard of gathering that information. The end result is kind of standardized, but the beginning part usually isn't.
I suppose it's hard to have a one size fits all just because of the nature of what it is. It's always going to be company and organization dependent. But I guess it's also similar to just anything really. As long as you have a standard and stick to it, there might be like a baseline for the minimal information that should be in there, but otherwise it's up to you, sort of thing.
Yeah, and if we consider, for example, one of my clients where I do work, that we have conceptual models in a tool from which we can export them as JSON files. And because that means that all the conceptual models contain then these sort of similar data elements, we just have some scripts that turn those into actual old ontologies. So it becomes sort of a computationally very simple process of formalizing that structure then.
Yeah. Okay. Makes sense. Thank you. Okay. Another question here. How do we avoid structural modeling collisions between concept models, taxonomies, and ontologies?
So this is a difficult question. There's possibilities for all sorts of collisions. The granular approach that John mentions there means that modeling work is being done in multiple different places, often by different people. And this is kind of what I meant with the almost the last slide there with the feedback loops, that we need to have some sort of a process where someone is able to gather the information from all these different places and put it together in a way that avoids collisions and avoids kind of defining customer in 7 different ways and finds the way to do that. So I do think that even though I am a great proponent actually of data mesh type of federated model in many organizations above certain size, I do think that to manage this kind of higher level enterprise semantics, we need to have some kind of information architect role, or at least some sort of group of people who will come together and figure out the sort of synchronization, at least between these different smaller models and definitions that exist in different places. Yeah, John's saying he's available. Yeah, I mean, he would probably be very good at that kind of work. But I think, yeah, you need to have that as part of the process. You can't just trust that everything builds up from the grassroots level sort of organically. That will never happen. It has to be sort of a guided process from the sort of grassroots level towards the enterprise level.
For those of you who don't know, by the way, with our data community events like these now, we do a podcast afterwards with the presenter. So some of these questions are probably going into more detail with Juha after this. So stay tuned for that as well. I've got a few questions to do a deeper dive on. So to have a look out for that. There are some questions around. We've got a few minutes left. There are a lot of questions around inevitably the AI applications of this kind of thing.
Yep.
Do you have anything you want to say about how that could work? Specifically, there's a question here on do you really need to split up the planes? Doesn't that all end up in the same context? How would you practically implement this for AI? There's two of the specific questions there.
Yeah. Well, I think the question of do we really need to split up these planes, it is not a question of utilizing that as much as it is of managing that. So let's imagine now that our AI agent comes to the knowledge plane and figures out something from there. It probably needs both the kind of actual physical data from the data plane and the definitions from the knowledge plane. And yes, it is true that all of that information from both of those planes ends up in the context window of that same agent. That is true. So eventually this happens, but it is way more difficult to maintain that semantic information if it is kind of included in the data plane. So if the data plane also contains in it all the semantical information, then we end up with the silos. So the separation is because we need to be able to manage semantics on itself and as itself, rather than combined to those data objects.
I think we'll go into in the podcast probably a bit more on the AI aspect, because there's lots to talk about there, I think. One last question I had: it'd be great if there was an end-to-end implementation example, like an example business domain. Do you have that available on any of your public material at all?
No, yeah. I know that would be really good, and I have been looking for something like that myself. Haven't found any. Obviously, I'm just one single man consultancy, so I don't get access to all those company results.
Yeah, I appreciate that. Yes.
Yeah. So I would love to do something like that, but haven't been able to do anything like that so far.
Okay, no problem. I guess if anyone starts trying this out and has something to contribute back to the community, please let us know. And if you want a platform to do that, reach out to us. One other question was how is the connection between the data and the knowledge plane implemented? Is this part of the data model too? Just some clarification on that would be useful.
Oh yeah, this is a very good question. I actually have a full article on this on my Common Sense Data blog. But this semantic linking issue. So basically, if you remember from that diagram, from Juan Sequeda's diagram, we had three kinds of metadata. We had the business metadata of those glossaries and taxonomies and ontologies. We had the technical metadata of, these are the tables and columns that I have. And then we had the mapping metadata. Now, this is the question, where do we put that mapping metadata? And there are different options. For example, and this is an example, one possible example, you could have URLs in the metadata of the technical object. So you have a table in BigQuery, I don't know, and in the column comment on BigQuery, you actually have a URL that points to your actual knowledge graph. So that's your semantic link included in the metadata of the technical object. That's one way of doing it. Or the semantic links could be maintained as part of the knowledge graph. So in the knowledge graph, you have your term customer, and then there's sort of metadata representation of all those tables into which the customer is connected. And the connection you can find from the knowledge plane itself. Data catalogs try to do this. So you have the metadata representation of the technical data object in the catalog, and you have the term in the catalog, and you're able to connect them inside the catalog. So that kind of allows you to deal with the linking. But as I said, many catalogs are rather lacking in this kind of capability.
That's actually one of the questions I wanted to talk to you about in the podcast, is tooling around this. So we'll go into that in more detail. One final question I think we have time for. I'll just ask that very quickly. So can we say that semantics is about managing the relationships between data and knowledge planes?
Yes, plus it is also about managing the semantics inside the knowledge plane. It's the links and the kind of terms and definitions themselves. It's content as much as it is the connection.
Yeah, okay, that makes sense to me. Okay, I think that's all we have time for. We've asked many questions there. Thank you very much, Juha, for asking all of those. For answering all of those, and thank you so much everyone for attending. It's been a really good session, lots of attendance, also good questions and engagement. Thanks so much.
Thank you.